A common theorem in high school geometry is the Pythagorean theorem. It applies to right triangles and it provides the relationship between the sides of a right triangle. There are hundreds of proofs of Pythagorean theorem. My plan is to provide 3 separate proofs in 3 separate videos, and in this first video I'm going to set some terminology for right triangles. If you have a right triangle, that means one of the angles is 90 degrees and the side opposite to the 90 degrees angle is called hypotenuse. It's going to be the longest side, so that's the hypotenuse, and the two sides that form the right angle, they are called legs. So a right triangle has two legs and a hypotenuse. And if I denote the legs by A and B and the hypotenuse by C, so let me redraw my right triangle, and there are two legs, call them A and B. It does not matter which one is A and which one is B, but the hypotenuse, the longest side, we want to denote it by C. So this is hypotenuse, legs, and we are using these letters to denote those side lengths. And there's one other thing we will be using in this proof. The idea is, since all the angles in any triangle add up to 180 degrees, if one of the angles is already 90 degrees, then that means the other two angles should also add up to 90 degrees. So this one is an acute angle which is less than 90, and this is another acute angle. They don't have to be equal, but they will add up to 90 degrees. Or in other words, these two acute angles of a right triangle are complementary. Now here is the statement of the theorem. The theorem says that if I square the legs and add them, a square plus b square, then that is equal to c square. So smaller sides square then added will give you square of the hypotenuse, which is the longest side. Now let's go ahead and draw a square for our proof. So here is a square that I want to draw. So let's go ahead and draw a square. So since this is a square, all the sides are equal and all of the angles are 90 degrees. Now let's start at one point, walk along the boundary and come back to that point. And as you walk, maybe say this distance is A and this distance is B. So this length of this square is A plus B, and you want to mark a point. So this length is also going to be A plus B, and when you walk, you want to mark again a point on the side AB, and you have come here. Now on this side again, after going distance of A, you want to mark a point. So this is going to be A and that's going to be B. And now we are here, we will mark another point on this side, A and B. And let's join these 4 points this way. So from this, I want to join this point on the adjacent side, and from here let's go to that, then join that and join this. Alright, now what do we notice? We notice that the legs are A and B. So what we have is 4 smaller triangles or 4 right triangles inside the big square with side lengths or with legs A and B. So then this is going to be the hypotenuse. And also notice we have A, B and C. So this is side lengths of AB, so this hypotenuse is C and this hypotenuse is also C because the legs are A and B. And notice that these 4 triangles are congruent because their sides match. Legs are A and B, hypotenuse is C for all 4 congruent triangles. And also we want to pay attention to the angles. Notice if I take a specific right triangle, then let me mark one of the acute angles with a single arc like that and the other acute angle, let's denote it by 2 arcs. Now notice if this is congruent to this, that means this angle will be the same as this. Alright, so what is this angle? This is between hypotenuse and long leg if you want. So this angle is also between hypotenuse and long leg. So let's go ahead and mark those angles. So between long leg and hypotenuse, if I use a single arc, then the other angle will be the double arc. Long leg, hypotenuse, if that angle is denoted by that, we have this. Now, look at a specific point, maybe this point. This angle is 180 degrees because it's a straight line, and these 2 angles are complementary because single arc and double arc, they add up to 90 degrees, which means this is also going to be 90 degrees. So let me go ahead and we can use the same logic and say that these are right angles. So what do we have here? This shape, this 4-sided figure, it already has equal sides. But now we know that they are equal angles as well, which means this is, and they're all right angles, which means this is also a square. So what we have done is we have taken a big square and inside we constructed 4 right triangles and a square. So if I look at the area of the big square, so let me write down area of the big square is equal to a plus b times a plus b because that's a square with side length a plus b. Now what about area of one of the right triangles? So let's go ahead and write that. Area of one of the right triangles or one of the triangles. Since it's a right triangle with legs A and B, its area is going to be half AB because it's half times base times height. One of these is the base, the other is the height. And then area of the smaller square is going to be C square because its side length is C. So what I'm going to do is I'm going to equate. So area of the big square is A plus B quantity square. This is made up of 4 triangles, which means it's going to be 4 times area of each triangle. So each triangle is half AB. So 4 triangles would be 4 times half AB plus the smaller square, which is C square. And let's go ahead and expand. A plus b quantity square is a square plus 2ab plus b square. Now notice you can't just say this is going to be a square plus b square. You can't distribute the square. You have to write a plus b times a plus b and use the FOIL method or apply the distributive property twice to figure out. And then 4 times half is 2, so it's going to be 2ab plus c square. Now if you subtract 2ab from both sides, what do you notice? You get a square plus b square equals c square. So this is one of the proofs of the Pythagorean theorem. We will have 2 more proofs in 2 separate videos.